I thought I did. I updated it on the main page.
Okay. So when I go to the meetup, there's like, yeah, there's just like a little like side panel with the Zoom link, and yeah, it says Clojure-Provo, and then it's got the time 7 p.m. to 9 p.m. MST and online event, and it's got the old Zoom link.
Really? Right now it does?
Yeah,
So I definitely okay, I'll go look at that again.
I think I think Meetup has like some extra long cache expiration or something. Um,
Okay.
because I've noticed it takes a long time for some things to update sometimes.
So this is all only gonna have been man, okay. We have 150 people, which puts us at 50 people over our limit. And we were gonna do like this first come first serve thing, but this makes it complicated. Sean, I'm sorry, man. I hope I didn't ruin our meetup tonight.
Well, a lot of people aren't going to join till the time of the meeting anyway, which is, another 15 minutes, 10 minutes.
Yeah,
So
exactly.
it's fine.
Okay. And Jacob is there. So Jacob, I'll make you the host. Yep, you're a host. So you're good. So thank you, man. Oh, why is this thing? Okay. Yeah, make host. There, you should be the host now. Cool. Thanks so much. Yeah. See ya. Okay, he's awesome. Okay, cool. So I think everything then on this computer I can just leave as is. We're recording. I need to figure out how to cut that out. And then Sean, did you get the waiting room set up such that you don't have to manage the admit, not admit, et cetera, et cetera?
You muted.
Oh, he is muted. No.
I'm muted because I've got multiple screens and multiple mice. Yeah.
Okay.
I've set it up so anyone who's got the passcode can come in, so we don't have to worry about a waiting room.
I hear it. Okay, I just have to expand this.
Yeah.
Sweet.
So
Okay,
I just figured that would be easier.
10 people so far. So, all right, cool. Okay, I'll be right back then.
Here's the ball.
I'll stop sharing until we're actually ready to start.
Okay, sounds good. Shoot. Oh, I'm not muted, am I? Okay, Sean. I wish I could take you out of the. I have to manually mute everyone. So, guys, we're gonna go. We're gonna kind of go into the mute unmute policy idea that we have when we get started in a couple minutes. But I was playing around just now with the mute all, and okay, yeah, I don't know how to exclude you from that, Sean. Sorry.
No, I mean, what should happen is everyone should join muted, because that's what I put in the meeting. And if we get people who are making noise and don't realize it, I think you can ask them to mute, or you can just mute them individually.
I can mute them individually.
Yeah.
Okay, that'll be fine. Right now, it's just the list is growing. You know, it's like, oh, 5 come, 5 more, 8 more come. So I'm like, can I keep up with all this? Probably once everybody's muted, then I will be able
Yeah, this is why I didn't want to have a waiting room and have to have someone click on every single person as they came in.
I hate the waiting room. I'm glad we figured out today how to kill that once and for all. So, because normally I have to sit there and watch it and try and manage it, and it's a huge pain. So, okay, cool, guys. We're just waiting for our 7 o'clock start time, just to give everyone a chance to get here. We're not going to do intros tonight, so if anything wants to just kind of make casual comments right now, go for it. Just have anything you want to blurt out there? Programmers are such quiet people. I need a collection of like pet crickets or something, you know? Okay, so I have to monitor this other one a little bit. It looks like all the people from BYU are hanging out on this channel and they're coding. So
Ryan, tell us more about the Provo Clojure group. I've never heard of it before. This kind of popped up on the interwebs.
yeah, cool. Okay, yeah. So we started Clojure-Provo around February, right as COVID hit. And the idea was, you know, some of the guys up north had a Clojure meetup that was going for a little while. And they were kind of, you know, I mean, meetups sometimes get to be a pain to manage and run all the time. So there were some of us down here a little more south in Utah looking to get a Clojure group going. And, you know, we started it, and then we were planning our very first meeting, and it's like, okay, social distancing, nobody meet anywhere. And I mean, I think it was right around the time even we were about to go into lockdown, and we said, let's do an online group. And yeah, that's basically it. So we kind of had some bobbles in the middle of the summer, as far as like how to, what should we do? Are we trying to do local or online? Do we want to try and have a part, part online, part local? And then started finding people to present and just kind of went from there. So we've been going strong ever since. So yeah. So cool. It looks like people have been able to find the meeting, and we got our 7 o'clock time. So let's just go ahead and get started. I have a quick little intro script for this one. So find it. So yeah, welcome to the Clojure-Provo meetup. I think most of you know we have quite a treat tonight, a little bit of a Christmas present. Sean is going to do some live coding session with emphasis on maximizing the utilization of the Clojure REPL. And in the interest of maximizing both his coding time and your question time, we're going to forego our usual casual entry time and just get right into it. So I only want to briefly open the floor to announcements. And I'll just go first with a quick short announcement that I'm doing on behalf of Bonsai, a local Provo Clojure company. So they're looking for a senior Java, Scala, or Clojure developer with a strong DevOps emphasis. And they have a relatively small dev team and need things to be streamlined. Basically, their CI/CD processes streamlined to be improved and running smoothly so that they can continue scaling at rate. And so if you're interested, it is a on-site starting post-vaccination. Contact Kenna Martin, and then I'll also post her job description, a link to the job description and her email in the global chat. And so, yeah, I'd like to open the floor for anyone else who might have announcements at this time. Okay. Ping me if you do have an announcement, then we can get you on the floor if later on if something comes up. So Sean will go into some more detail on the format, but the idea is live coding. So feel free to inject at any time. Live coding, live audience. So I'm going to watch the mics, like you might have heard us talking about, and mute them just to make sure if there are any random noises. Don't take it badly. If you get muted, just go ahead and unmute yourself. Always look to unmute yourself before you jump in with a question. And yeah, with that, let's get started. Everyone, please welcome Sean Corfield.
Hi, folks. So I do have a few slides, mostly just to sort of set the tone of what we're going to be talking about and what I'm going to be showing. It's also occasionally going to look rather strange because I have two computers here. I am using the AV from one and I will be coding on the other one. So when I'm looking like this, it's because I'm staring at my screen and coding. So don't think that I'm no. Okay. This guy is attacking my microphone. I may have to wrestle with cats. We have quite a few cats here, and we love them to bits, but they can be very insistent when I'm on meeting calls like this. So, REPL-driven development. I'll tell you a little bit about who I am first, and then we'll talk about the REPL itself, and then I'm going to fire up a REPL and an editor, and we'll build something. I've been a senior software architect for a bunch of companies for about the last 20 years now at this point. Currently at World Singles Networks, we're online dating. We have over 40 websites. We have, I think we're probably close to 110,000 lines of Clojure now. And we've been in production with Clojure since 1.3, one of the alphas. We are currently running 1.10.2 Alpha 4, I think, in production. With RC1 going up, we've run pre-releases of Clojure in production for years because it's always so stable. I maintain a bunch of open source libraries you may have come across. Mostly they're database related. And kind of funny, when I first got started with Clojure back in 2010, 2011, really no one seemed to be using JDBC and relational databases with Clojure. And it was just about the time the huge contrib library from 1.2 was being broken up into individual libraries for 1.3. And I wanted to use the Clojure contrib SQL library. And no one was maintaining it at that point. Stephen had stepped down. And I kept sort of pressing and saying, you know, can someone pick up this library? We really want to use it at work, and you know, it needs a maintainer. And eventually the core team said, well, you know, why don't you maintain it? And so that was kind of how I came to start maintaining libraries for Clojure. And if you use JDBC libraries, thank you for using them. And I'm always looking for more input on those. My journey to Clojure is kind of perhaps a little long and a little odd for most folks. I started a long time ago, so I started with assembler and COBOL. I even did some Cold Fusion. You'll see that I'm wearing my Cold Fusion Lives t-shirt tonight with the zombie Cold Fusion coming up out of the ground with a lightning bolt. But I started doing functional programming at university, and it was kind of really nice to come back to it and find that languages like Scala and Clojure were being used for real world work. So that's where I got with that. REPL-driven development. Lots of languages have a REPL. So you talk about Clojure and its REPL-driven development. Lots of other people in other languages go, well, hey, my language has got a REPL. But most of those REPLs aren't the same. They are interactive consoles. They are often interpreters rather than the full-blown compiled version of the language. And you generally don't have a REPL that leads into a live production process that you're working with. So, you know, that I think is what really sets our REPL apart. What I'm going to be showing in the coding session is starting up a REPL and actually building an application live in the REPL. So, and it's the way I work with things normally. I have a REPL running that is the application. And if I need to, when I run tests, I run them in the REPL. And it's the live service that is our dating system that I'm usually running while I'm working. And I pulled out this quote. If you haven't seen Stuart's talk on REPL-driven development, it's 3 years old now, but it's a really good talk. I'll give the link at the end. And he said, I'm baffled when people type things into the REPL. And this is one of the things, of course, the tutorials will say, well, start a REPL, type in these expressions. And if you are using the REPL that way and you're just typing into it, you know, it seems just like the same sort of interaction that you've got in other languages. But if you connect it to your editor and you do everything from the editor, you can have a record of everything you're working on, and you know, you're not typing into a REPL without all the niceties of, you know, paredit or parinfer or whatever else is in your editor. Some caveats. I expect things will go wrong at some point. You know, developing code never goes terribly smoothly. I am using the Clojure CLI for this and my .clojure repo and all of the aliases that are in there. This will all work with Lineagen or boot, whichever you prefer. I am using a pre-release of the CLI, but it won't affect anything I'm showing. If you're using a newish stable version, that will have all the same features. I have recently switched from Atom and Chlorine to VS Code and Clover. It's the same extension package maintained by the same person, so it's now the exact same functionality, but what I'm going to be showing you could do with Emacs or IntelliJ or whatever else is your preferred way of working. And I use a socket REPL, just a plain socket REPL into any process that I'm working with. So again, you could do all of this with nREPL. The reason I like the socket REPL is that you can just provide a JVM option at startup for any process. and that will run the socket REPL on whatever port you want. You can actually get it to choose a port automatically, which is something I discovered fairly recently. But the nice thing there is if your tooling works with the socket REPL, then what you do in development is essentially exactly the same as what you could do on connected to a remote system. And we do run socket REPLs in our production code. And I do, from time to time, connect directly to the production instance that's running. And we have applied patches live to the running application in production using a REPL at times. The other thing I'll mention is that I'm using a branch of ToolsDeps Alpha that provides sort of dynamic adding of libraries to a running REPL. I do it because it means I don't have to stop and restart my REPL when I need to change my dependencies. You can do this with Leinigen because you can use Pomegranate, which is, I can't remember whether you need that as a separate dependency or it's built in, but you can use Pomegranate to add new dependencies live while the REPL runs. The other thing I'll mention is that I'm using Reveal, which I think is a great open source project from Vlad with 3 A's. You'll see him online. And it helps me sort of visualize the structure of the data that I'm producing. It's completely optional. There's a browser-based project called Portal, which does some very similar stuff. And Cognitect has Rebel, which was kind of the first read eval browse loop that does visualization with graphs and stuff. I'm not going to be doing anything with the graphs, but I did want to mention that because I am relying on it so much for everything I do. I do want this to be interactive. If I do something and you don't follow what I'm doing, please unmute yourself and ask. I'm keeping an eye on the chat as well on this machine. So feel free to dive in and ask questions. What I'm going to do is start with a brand new minimal project from scratch. I'll start up VS Code, I'll start up a REPL, and the idea is I'm going to build a small web app, and we'll see how far we get. And it is entirely up to you, in a way, what you get out of this, because if you want me to show something specific, just ask, because I'm happy to drive this in any direction that helps you. So let's go to an empty folder, and I am going to create a brand new application. Saw the comment in chat about Cold Fusion. Yes, I made a lot of good friends in the Cold Fusion community, and I still keep in touch with them. Okay, so we have our basic app here. You can see it's literally just got a minimal source and a minimal test folder. There's not much in here. Start up Visual Studio Code, and then I'm going to start the REPL. Now, as I said, I'm using the aliases from my .clojure repo, so there's going to be quite a few things I'm going to put on here. I want to use Rebel readline as the actual interactive REPL, although I'm not going to be typing it in too much. Reveal, because that's where I display all the results. I want the test code on the path. I need the adlibs branch, and then my dev tooling. So if you're curious about that, you can go look at the repo. I'm happy to talk about it here as well. Dev is an alias that runs a small CLJ script that's actually in my .clojure file folder with the deps for all this. And it looks at what's on your class path by trying to require and resolve various libraries. And it will start a socket REPL. It will start Rebel readline, Cognitect Rebel if it's on the class path, Reveal if it's on the class path, and so on. And so we have a little Reveal REPL here popped up alongside. And we're just going to open up, here we go, and connect to the REPL. Now, I don't like a big REPL window, so I tend to minimize it down to the bottom, and we'll just make reveal as big as that. Now, the right-click view that I just did there, this is just some little customization in Reveal that I've got that automatically displays values in table form with their metadata below, because I just find that useful. And here's our main function. Let's just evaluate it. There we go. So we've got that. And now we'll start to actually build something. So first of all, we're definitely going to need Ring, because we want that to build a web app. So I'm just going to create comment. Now, Stu Halloway calls these rich comment forms as a joke, because Rich Hickey uses this approach as well. And the idea is you don't type in the REPL, but you can keep scratch code around in comments. So it's not going to affect any of your production code at all, but it's going to allow you to keep a record of what you did and how you were thinking while you were working on stuff. So we're going to need to require Clojure tools alpha REPL and refer in the add libs function. And then I'll just evaluate that. Okay. And then I can now add libs, and I want to pull in Ring. And I happen to know that the version I'm going to be working with, I think, is 1.8.2. And what we see here straight away is I've evaluated that, and I'll talk a little bit about the hotkeys and things. I only use a very small number of hotkeys while I'm working. But what we see pop up in the window here is a list of all of the projects that Ring brings in. So it brings in Hiccup, and it brings in the namespace tracker and crypto equality, whatever. But the add libs is essentially saying, okay, I'm going to look at what you've got loaded. You don't have this library, so I'm going to go and find it, pull it in, and it will return the list of all the transitive dependencies that it's essentially brought in. So what I can do now is I can say, okay, well, I'm going to require, so used to typing into comment forms, we need the different format here. Okay, ring dot adapter dot jetty, and then I will evaluate that block. Now, VS Code is automatically saving things when I run tasks. I'm not saving the file, and I don't bother saving a lot of the time when I'm evaluating code. So, you know, this again is one of the convenient things. If you're just evaluating expressions or top-level forms, you don't have to worry about actually saving the code, loading the file, and so on. I see someone asked about the command for creating the new project. So this is using CLJ new, because I'm using the Clojure CLI, and I have an alias set up called new. Oh, look at that. Rebel readline has color highlighted my code. Okay, so back to that, sorry. The alias is :new, and that is aliased to the CLJ new library with exec function as CLJ create. And so this is a nice way with the -x option of running arbitrary functions in Clojure code from the command line. And then you specify essentially like named arguments, like you would in Clojure, in a Clojure function that takes named arguments. So you have keyword value, keyword value. Okay. All right. So having required Ring adapter jetty, let's say that you pull in a library, you pull in a namespace, and you're not really quite sure what's in it. So one of the things that we can do is you say, well, let's have a look at the publics that are in the namespace. And so if we do this ring.adapter jetty, and if we evaluate that, oops, there we go. So what we see is we got a map back of the names, the symbols that are in that namespace, and the functions themselves. And you can also see here, this is displayed in a nice little table in Reveal. So it's a nice way to just quickly glance through stuff. So what I'm going to look at here is I'm going to pull up the doc string for this to see how it's used. And you could do that directly in your code, just say doc and the name of the function. And we can see it takes a huge number of options. Okay, so I'm going to pull in just the run jetty function, and then I'll evaluate that top level block again. Probably a good point to talk about the keys I'm using. I pretty much only use evaluate block or evaluate current form, or evaluate the top level block. So if I'm in the middle of a function I've just changed, I can just hit a hotkey to evaluate the top level block, and the whole function definition is then sent to the REPL. And if I'm in the middle of a comment block, I'm usually at the end of a line, and I can just evaluate that one expression just with a hotkey to evaluate the form. Pretty much all the Clojure editors, when you're integrated with a REPL, should provide you with that. I do sometimes use load file. You know, when I get started, I will load a file up to get it sort of warm in the REPL, compile the REPL. But then pretty much after that, I'm only using evaluate a form or evaluate a top level form. Okay, so, and someone's asked if my Reveal customizations are available somewhere. If you go to my .clojure repo, which I'll give the link for at the end, you will see in the code there that the Reveal customizations are all actually part of my dev script. So that's part of what dev does, is when it starts up a REPL with Reveal, it actually installs the Reveal extensions and then actually evaluates that view, that custom view, into the REPL, which is why when I started up, it appeared with the right-click view here. So we're going to run Jetty, and let's see, if I ask for docs, we see the huge number of docs there. That's what would happen if you do doc on something in the REPL. You'll get it all as text, but we've already got it over here. So I'm going to need a handler, so let's write a little handler. All ring handlers take the request, which is the hash map, and all I'm going to do here is just return status 200 and a body of hello world. So we'll evaluate that block, come down here, and then this is a little trick when you're working with REPL and you want to be able to redefine functions. If you use a function in a function call, it's going to get looked up every time, so you can redefine functions and calls to it will work. But if you're passing functions as arguments, what will happen is when the form is compiled, the current definition of the function is what's used, and the function value itself is passed in. So once things like that happen, you can't just redefine the function on the fly. But what you can do is you can specify it as a var reference instead. So if you use #quote and the function name, that creates, that provides the var reference rather than the value of the function. And then you can redefine it on the fly, and you'll actually see the changes live, which is one of the keys to doing REPL-driven development. So we'll put this on a fairly random port. The other thing that we need, if we look down here, we see by default, run Jetty will block the current thread until the server ends, and we don't want the thread to be tied up. We want this to run in the background so that we can continue interacting with the REPL. So we will have join false. And so now I should be able to evaluate that. And what I get back over here is a server object. Let's get rid of the docs here. Let's go back to this. Not much we can see about this other than that it's an Eclipse Jetty service. So we want to go and look at that. I'm going to be lazy and just type a URL in here and then jump from Revel and reveal into that. And so one of the things that Reveal lets me do is click on a link and pop it up. So here we go. Hello world. And to prove that I can change that, let's change this to Hello Provo. Evaluate the top level form only. Go back to the browser, and when we reload, it's changed. And like I said, that's possible only because I'm using the var handle here for the variable. Okay. So for a web app, we're going to want a lot more than just a bare bones handler like this. We're going to want to be able to deal with params. We probably want to deal with security, sessions, cookies, and a whole bunch of other stuff. So what I'm going to do is pull in a library called Ring Defaults, which provides all of that in a nice, neat package. And what I'll show now is a little trick that can be fairly helpful because you're going to have to keep your deps file up to date. You want your dependencies to match what you're actually working with in the project. And now I've already added one dependency and haven't updated my deps, so it's going to get out of date pretty quickly and out of step. Fortunately, what we can do is a little trick where we can treat this as code. So I'm going to put in a commented out form, the _, lets you put in code that you can evaluate with your editor, but won't actually be used by the program when the file is read. So this is a sort of short form for comment, and it actually completely removes the form. So comment itself, the rich comment forms that I'm using, evaluates to nil. This is actually reader level, and so the reader will completely skip the form. But because it's part of your source file, you can actually still evaluate it. So I'm going to pretend that this is a Clojure file. I'll give it a namespace. I'll put in here the require of the Clojure tools deps just because it's kind of useful to have it in here. And then I will evaluate that form. And so we get nil back, which is fine. We've now got a namespace in here. I'm just going to clear my REPL so new things pop up. It'll be easier to see. And then the other trick is I'm going to put a form in here from the other file where we've got the adlibs. And so we want to have the Clojure dependency in here. And now we have, let's just get rid of that. Okay. And so now we have a piece of code in here. You can see probably that it's getting other things are being flagged because this is no longer valid. Well, it is valid at the moment, yeah. So let's go ahead and check that that evaluates. Yes, it does. And now we're going to put in the ring defaults. And I don't remember what version that is, so I'm going to use a shorthand that Maven understands, which is release. Don't do this for production code. You really do want to go and find out what the version is. This just provides a quick way to get the latest version from Clojars or from Maven. And we see we get back that pulling in ring defaults has pulled in ring SSL, ring headers, and ring anti-forgery. Obviously, we don't want to leave this kind of random expression in the middle of our code here. So what I'm going to do is I'm going to just, because I need this to be lined up, because otherwise it will drive me nuts, because I'm OCD about that kind of stuff. But if I comment that out and then just stick the form in, now we'll see we have this form that's hidden because it's essentially a reader comment. And now the file is still valid as EDN because we've got two pieces in there that are going to be thrown away by the reader. And the deps key here still has the hash map of dependencies. But we've now got ring defaults in, so we can go back to our code, and now we can start to pull in more of that. So ring, I think it's ring defaults. Let's just see. No, it's not. So it's going to be ring defaults probably. Nope, I will go look it up. That's ring defaults. Ring middleware defaults, there we go. So, ring middleware defaults. We get nil back, so that's good. Let's put this up so we can see. And the two things we're going to want out of this are site defaults and wrap defaults. Okay, so what we're going to do now is we're going to, while the REPL's running, we're going to redefine our function here. So I'm going to rename it to app first because I need a new function called handler because that's what I've told runjetty I'm using. So now we'll put in the handler function. And I'm going to do it as a function first, and I'll explain why. We're going to want to do, oh, no, I will do it as a def form and then talk about the downside of that. So we're going to be wrapping our handler in defaults. So wrap defaults. We'll use the app there, and we want site defaults. And we've done it as a def form. So there's a thing here. When you evaluate a def, it's going to take the current versions of whatever you've got, and you're going to get those current values and not be able to rebind them. So if I go back to our Clojure-Provo, that still works. No, it doesn't. Now it wants to download. Now, this is something that has caught me out a few times when I've started with web apps. Importantly here, I didn't say what content type this handler was returning. So part of the defaults in ring default is to try and guess the content type, and if you don't have one, it'll put in a version that's, I think, essentially bytes. So it tries to download your page as just data. So we also need to make a change to this. We're going to start to use some of the nice utilities that we get with Ring. So ring util response, and I'll alias that as response, evaluate, and then come down here. And so what I want is to take a response of hello Provo, and then tell it that it has a content type text HTML. Okay, so evaluate that, come back here, and this time it should actually just reload. There we go. Okay. So this actually will deal with parameters and so on. So now one of the things we can do is we could say, we could start to use parameters in here. And so I'll break this up and see if we can get param's name. So you get all sorts of niceties with ring defaults. You don't have to do, you don't have to pull in all the different middleware and wrap everything up yourself. Okay, there's another question there. Am I using anything else of VS Code besides Clover? Yes, I do have some other extensions in. You'll see from the Cold Fusion t-shirt, I also have a Cold Fusion extension in VS Code. CLJ Condo, love CLJ Condo from BorkDude. That automatically checks your code as you're typing, and you get little squiggly lines when it doesn't like something. So for example, if let's see, if we just put in a function that we're not going to use, let's just say we have a private function foo, and we see the little squigglies under foo, and it says unused private bar. So CLJ Condo is really good for linting your code as you're typing. And because at work we are a Atlassian shop, I have Jira and Bitbucket, which I must admit I'm very impressed with the extensions and the integration with VS Code. The only other stuff in here is I use rainbow brackets, which is why I have yellow, red, green as I nest code, and paredit. And I use the strict paredit, which is a more up-to-date version of the paredit extension. Let's see, is there anything else? I thought I had parinfer. I think I've turned, oh yes, I do have parinfer. So parinfer is in there as well. Okay. Okay, so we've got params. One of the things that someone asked me to show is using tap. You'll notice that my reveal window says tap on everything. The integration that I've got with VS Code with Clover is that in addition to sending values to Clover's REPL, which prints at the bottom of the screen, this also uses tap, which is how it sends everything to reveal. And if we were to pull up the original REPL that I had, just to show, if we evaluate things in there, they'll show up in reveal here, and you'll see it's shown slightly differently. It shows the value that was typed in, and then it shows the little equals arrow and the result. If you are evaluating things in your code using tap, and you've got something that's listening for tap values, that's a really nice way to do debugging, and that's some of what I'll show here. So let's put a tap in here, and we're going to tap the ring request so that we can see what's in it. And if we go to our browser now, and I will okay, so we've had a request has gone through, and if we go back and look, we'll see here is the ring request. And let's pull that up. And so headers, cookies, session keys, a whole bunch of things, and reveal is showing it to us in a table as well. So it's easy to sort of scroll through and look at things side by side. One of the nice things about when you're using Reveal or Rebel or Portal is that you can sort keys for display. And so now we have them all in order. And we can see anti-forgery token and body and all these various bits and pieces in order. So when I'm working with web apps, I use a library called Selma. I don't know how many of you've worked with that, but I really like Selma because it's a nice templating language. Hiccup is kind of the other thing that you could use for generating HTML. which is great if you want to build your HTML as data structures and you're working just as Clojure developers with it. But I work with front-end folks, and in particular, we have a UI UX person who will often provide me with HTML and styles that go on the front of the web apps. And I will want them to be able to interact with templates that I'm working with. So by using Selma, it's very sort of Django template-ish, where it uses braces for substitutions. So let's go and add that to the project. And again, I'm going to be lazy. I'm not going to bother going and figuring out what version it is. And then we just, in order to turn this into code, we're just going to put the quote there and evaluate that expression. And we see it's brought in the dreaded Jackson libraries. Anyone who's been working with JSON in Clojure will probably have encountered Jackson at some point. And once you've got a project of any size, Jackson is kind of the dependency hell of Maven, because so many things rely on it and they all rely on different versions. And so you often end up needing to pin your versions so that you get a predictable version of Jackson rather than getting random versions from your dependencies that you're pulling in. Okay, so I just switched that back. So it's still a valid deps file. And now we'll pull in Selma. I always alias it as HTML because that's what I tend to think of. And let's just quickly see what it does. Oh, another technique I should explain. If you're working with things like paredit and parinfer, they have a tendency to try and reformat your closing parentheses. So if I do that, you'll see the parentheses jumps up to the previous line. Both parinfer and paredit do this kind of thing. But we really kind of want it down at the end. We don't want to have the extra bracket on the end because it makes it hard to put the cursor there and then evaluate the form. So one neat little trick, and I can't remember who said this, but I saw it on the Clojurian Slack recently, and they said, oh yeah, I put a comma before the closing paren, and then parinfer and paredit don't try and attach it to the previous line. And I thought, oh, that is such a useful idea. And now it'll stay put, it'll stay down there, and I can type in expressions. So let's look at, here we go. So we get render. And just to give you an example, let me just see what that takes. Okay, so render takes the string and the context map. Okay, so talk about templates. So if we said, well, we've got hello name, I'm going to put this in a file in a minute, and then the data that we're passing in has the hash map. And so we evaluate that and we see we get hello Selma. So it's substituting these things in. And it's got some basic controls like loops and conditionals. So that works pretty well for building all of our templates. We don't have a lot of actual web pages. Mostly we have a React-based front end. It's all written in JavaScript. And it makes API calls, but we do have some things that generate HTML pages. And in fact, all of the emails that we send to our customers are all done through Selma and these templates and generated and sent out. So let's create a new file. We're going to put this under the resources because that's where, oh, and my screen on the laptop has just gone black, so I don't know why has that happened.
Had to happen at some point, right, Sean?
Yeah, something went wrong. So it's still broadcasting and we still have my audio, but my laptop screen has just gone blank. So I can no longer see chat. Okay. Well, I will deal with that later. Okay, so we're going to put a folder in here, and typically what I do is I'll put all of my HTML templates under a folder called templates. And under there, we'll put a new file, and we'll just call it hello.html. Okay, and so what we want to put in here is what we had in that template. Okay, and now, just to prove that that works, we will render file on that, and we're going to pull render templates hello.html. And there we go. So it's read it from the file. It's nice. Soma will automatically refresh if you change the file. So the next time you run render file, it'll update its cache of the templates. So now we can start to write HTML pages and actually have things happen on the page. So let us have a little form. Method equals post action. And we'll just submit back to ourselves at the moment. And we'll put a submit button. I don't do a lot of front end work, so you'll not see anything fancy or stylish in any of this.
Hey, Sean, maybe you could go into a little bit on your strategy or theory on the separation of GUI and backend in Clojure versus non-Clojure.
I don't know that I have any strong opinions as to it being different in Clojure. I mean, we just happen to have built things that we have a JS front end and a React app, and it talks JSON and REST to the API on the back end. I mean, you know, I don't know what's really to be said there. Can you clarify what you're asking, maybe?
Well, I guess the Clojure script ideas of generating, using Clojure script and a hiccup to generate the totality of the HTML JavaScript kind of paradigm versus what you guys have done at World Singles and kind of what you're doing now, where you're isolating them. You're putting the HTML and JavaScript in the front end, and you're keeping Clojure script only on the back end.
Right. Yeah. I mean, we did look at using ClojureScript. We looked at using ClojureScript probably back in 2013, early 2014, and it was really kind of a different beast back then. The tooling was very clunky. The whole thing was pretty fragile, and there was a lot of churn. So we decided at the time that JS was battle tested, and we would build SPA. When we got around to building it, we'd build it with JavaScript. And so that's why we went that way. If we were starting from scratch, would we do it differently? Maybe. We will be rebuilding one of our small server-side rendered HTML-based apps at some point and sticking an SPA on the front of that, and we might well decide to use ClojureScript with that. Like I say, I generally don't do any front-end work. So, you know, my HTML and JavaScript and CSS skills are very minimal. And I rely very heavily on my colleagues to provide all the nice affordances that people expect these days. Does that help? Does that answer your question?
It does. Yeah, it does.
Yeah.
Yeah.
So,
since you were interrupted, can I ask if you use transit at all for communicating with the front end?
No, and part of the reason for that is that the JS requests that we make to the app are mostly pretty simple. We're we are occasionally passing a structure back and forth, but it's pretty much, it's not going to be something that Transit's going to really help us with. And it also means that we can stick with pretty much sort of native JavaScript on the front end without having to worry about a transit library for the front end folks. So if we were doing ClojureScript, maybe we would consider it, but to be honest, JSON EDN is pretty nice to work with, and you can watch it going over the wire when you're debugging things. If you're doing stuff with transit, I don't think that that's as easy. So I haven't used transit, so I'm just kind of guessing there, but it's not something that I would think of using. Okay, so now what we're going to want to do is render the form with that. So we're essentially going to put this as our line in here, and we're just going to pull the params out of the request. So whatever's in the params we'll be able to get at in the template. What we do in our apps at work where we're building a lot of these templates is we tend to pass in a structure that has the params from the request and other data that we're slapping around. For the emails that we generate, we put in the hash map that represents the member that we're sending stuff to, a hash map that describes the site that it's associated with. As I say, we've got 40 different dating sites. So it's nice that you can control what data goes in there. And let's see. Okay, so we've got the app done. Now, when we come back to this, we'll see it's picked up the rendering of the form. And so we say, okay, let's greet someone. And we get this. I don't know how many people have worked with the ring defaults and the Anti-Forgery Library. I always forget when I'm working with this that it needs some more data. Because one of the things you actually have to do is you have to provide this anti-forgery token every time you're going back and forth. So I learned eventually when I was working on this that we're going to put this in here, ring, I think it's ring middleware anti-forgery, if I remember correctly. Ring middleware anti-forgery, and we're going to just refer the anti-forgery field. See if this evaluates. Just pull that up. And did I get an error? Yes, I did. Anti-forgery field does not exist. Okay, I will now go look at the docs again. Ring anti-forgery. You can see that I've been looking this stuff up when I've been working with it before. So they have somewhere they tell you about the HTML field. Anti-forgery, anti-forgery field looks like that. Ah, it's because it's in util anti-forgery. Okay, so ring util. Okay, so let's see. There we go. So now we've got a successful evaluate. And because that's going to annoy me, let's move it down there. I have to keep my namespace requires in alphabetical order. I don't know how OCD other people are about that. Okay, so one of the things that we're going to have to do is, in addition to passing in name from the params, we're going to also want to pass in something that we can render in our HTML with that anti-forgery token. And if you remember when I showed the the ring request in tap. View it as a table so we can get it back quickly. There's an anti-forgery token in there, and the middleware uses that to verify that your form posts are not being spoofed or scripted. So it generates a new token every time. So let's put that in as well. So I'm going to create a token field. And we will put this in as the data that we expect. So we'll keep them separate. Okay, so evaluate that. And that means that this is going to be data.name now. And we're going to need this hidden field in here, which is token field. So let's see if that will work now. And we get it all splashed into the HTML. One of the things that Selma allows us to do is say that we know that this is safe, we know it's HTML, and we want you just to put it in the form, in the HTML page exactly as is. And so now we've defeated our anti-forgery token, and we're actually getting the security from that as well. Okay. So how are we doing on time? Looks like we're coming up on 7 p.m. Pacific.
Yep.
And
8 p.m. MST.
8 p.m. Yeah. So, you know, I can continue and show other things. I mean, my script goes a little further than this for building stuff. I will sort of take a break now to talk a little bit more about some of the things that I do. When I showed the NS publics to find out what's in a namespace, I have a hotkey that essentially does that automatically for me. So when I'm working with a library and I want to know what's in it, I can put my mouse onto something and hotkey that will go and generate that. And we can see here, if I put it on, say, the anti-forgery one, there's only one function in there. If I put it on response and ask for that, come on, reveal, catch up. There we go.
Hey, Sean.
Yeah.
Hey, so what were you thinking on time? We're scheduled to go for one more hour, but
oh,
we're already...
yeah. I mean, I've got the room set up for that. I don't want to take up too much of people's evenings. I do have a few more slides I want to do right at the end of this.
Yeah.
But so it's up to folks, you know. Do you want to keep going? Do you want to ask questions? I want to make sure that I'm answering people's questions about, you know, working so focused on the REPL.
Keep going, man. We don't get to see Sean Corfield code every day. I do have a quick question. Well, not question. I don't know if now's good or
yeah, sure, absolutely. Yeah, like I said, dive in.
So you said you have a REPL in your production environment.
Mm-hmm,
obviously is super powerful, but I'm really curious, do you know any way to have anything like a secure REPL or a monitored REPL or some kind of REPL that would keep, you know, compliance happy? Do you know any techniques like that, or is it just like you really monitor who uses it and under what circumstances?
Well, first off, it listens on a local port, so the port is not exposed outside the server. So you can only actually get at the REPL when you're SSH'd into it. So that's one thing. We don't run socket REPLs in everything. We actually have a fairly easy way that allows us to put a dot file in with our apps, and if we restart the service, it'll actually pick up the dot file, and that will enable whatever options are in there for the socket REPL. And so when I actually need to do that, I have to have a VPN up and running on my dev machine, and I have to have an SSH tunnel into the specific machine that I want to talk to, and then I can connect my editor to that REPL. Now, there's that level of network security. Is there the issue that I could blow up one of the production processes by evaluating something wrong into it? Sure, absolutely, yes. It's something we use primarily for debugging. We will do things like we will use it to run queries and run code against production, so that we're in the production app environment when we're debugging something. We do very occasionally redefine functions live on the fly. Typically, we have most of our processes in a cluster, so you'd need to go into each app and do it, so it's not really very practical for sort of deployment purposes. And we have an automated deployment where we basically send the jars up to production, and there's a process that says, okay, I'm going to take the service down, I'm going to bring in the new jar and start the service back up. But we have a couple of singleton processes, and those are mostly internal facing, and we don't want to have to take those processes down while, for example, all of our member support staff are working on something, and I'm able to apply patches to their admin console while they're working. So,
Okay.
but yeah, the other aspect of that is, would you want a REPL where you can't do the damaging things? And the answer there is yeah, but then you're going to be in something like Clojure or one of these other sort of limited REPL environments. And you're probably going to find that you're going to need to break out of that to do a lot of the debugging that you'd want to do. So.
Sean, I just want to make a quick side comment. In terms of the time, anyone who has to leave can get out when they want. We're on your schedule, man. I will stay as late as you want to stay. And yeah, if anyone makes Sean quit because they have to leave at 9 on the dot, you're banned from Clojure-Provo for life. Okay, all I'm saying. That's it. Right.
Okay. So yeah, so going back to some of the stuff that I eval and some of the stuff that's sort of built in, things that I do commonly, the NS publics on a namespace is something I do fairly commonly. The other thing that I like to have access to is the docs. And so although you can, pretty much all of the editor integrations will show you the raw doc string for something. So if I'm on find NS and I ask for the documentation and I see it pop up in the REPL, if I ask for information about the variable itself, we just get that there. But what will happen eventually when Reveal catches up with me, and I'm not sure why it's been quite so laggedly today. So we've got the metadata that shows up here, which I kind of like because it tells me the file and the line number, and I have the doc string showing up in full format down below. The other thing that I have, and again, if you go to my .clojure file, you'll see it in the aliases and the setup for VS Code, which is another repo there, is that I can ask it to go out to Clojure docs, and it will actually pull up Clojure docs inside Reveal. Reveal can do, because it's a Java FX app, it can actually do full web pages. So now I can pull up the Clojure docs for something that's in core and scroll through and look at examples. That one doesn't have any. And I don't have anything else in here that's core. Well, print line, I suppose. And so we get all the examples in there. And the other thing there is also you can pull up Java docs. Again, it's in the REPL. You can get the Java doc. And under the hood, that goes and gets the URL into the online Java documentation. And so if I was to take, let's just evaluate this. So let me expand and evaluate. There we go. So that's just a string. And if I hit one of my other hotkeys, this will go get the Java docs for the string type. and display that. So again, this is leveraging what the REPL gives you, in that you can get the Java docs, but if you've got something like Reveal, you can browse them directly while you're working. And so I tend to be able to, tend to work with pulling these things up. It only does the Java core library, but that's a pretty darn big library. And so you can navigate through. It's a perfectly usable little web browser. So that's another thing there. If you go look in my VS Code Clover setup or my Atom Chlorine setup, they have the exact same hotkeys bound in both, and they have all the code that is essentially between my editor and the REPL. So you'll see that there's really not a lot going on. There's not a lot of magic in any of that. It is literally just leveraging basic Clojure code to do some of that. And like I say, I have a core set of hotkeys that is pretty much all I work with. So I'm going to run through the end of the presentation, and then I will go back to the live coding, so folks can continue to ask questions. If I can get this to advance.
Hi, Sean. I had a couple of sort of somewhat related questions around debugging. Do you normally use any kind of step-through debugger? Because obviously it's a pretty small example app, but...
I don't. I mean, I showed using tap to get at values in flight, and that does actually tend to be the way that I work with that. I have no idea why this is not showing me the presentation. Sorry about that. But no, I just use tap. I mean, this is one of the things I like about having small, simple tools, is that tap will let you get at any data while your app's running, and will let you view that in whatever you've got attached. I talked about tap a little bit. I'll just mention tap. And in fact, that would be something to show the docs for. Tap came in Clojure 1.10. It is a very, very useful function that you wouldn't know much about from just its doc string. It says sends X to any taps, will not block, and very helpfully returns true or false. The key thing with this is that you can add essentially watcher functions, and then anything that is sent via tap will be sent to all of those functions that are watching, and you can add a tap and take it away again. So you can temporarily add all sorts of interesting debugging tools that will pick up all of that information that's flowing through your application and display it however you want. And then you can just take those taps away again. And you can leave the tap calls in your production code, and they don't really do anything. I mean, they send data to a queue that just kind of forgets it after a certain point of time. So tap is a very, very nice way of debugging.
Yeah, awesome. I guess that kind of half answered my second question, which was about taps. Do you use it for things beyond debugging, like logging and sort of any other sort of?
No, and one of the things there is that you need to be careful not to try and use it for anything that's kind of production level, and the reason for that is that it will drop things. It is designed to drop things when you've sent too much into the buffer. Now let's see, will this, yeah, there we go, okay. So it is really intended for a debugging tool. So I started to just go through these slides, and I'll now go back to the live session and answer more questions and show stuff. Don't type into the REPL. Don't type into the REPL. You never need to type into the REPL. If you keep using the comment forms in your code, you get a nice history of how you thought about stuff. A lot of our production code has comment forms scattered throughout it, which show kind of the path that we use to get to the finished code. We use spec very heavily at work, so one of the things that we'll also do is use spec to generate data. And so in our comment forms, you'll often see spec exercise on some spec where we're generating data, and we'll be using that to actually run through functions and test them as we're building things up. And it's also a nice way to put in things that are sanity checks, or even to run things like generative testing, which you don't necessarily want to run all the time. You don't want it to run as part of your unit tests because it can be very slow. And so it can be kind of nice to have a comment form in there that actually has a generative test in. Editors should, pretty much all editors should allow you to evaluate code that's in a comment. So, you know, it's not, again, it's not using any sort of weird magic with editors. I hope that, you know, having seen this, you realize that there's no magic. I'm using very simple tools. It's just a socket REPL. I'm just evaluating Clojure code into it. Reveal gives me some nice affordances, but the bottom line is there's nothing magic going on there. I don't use any refresh or restart tooling. As you saw, I started the Jetty server up and was able to add functionality all the time while I'm working on that. I typically have my REPL up for days at a time, sometimes weeks, and just keep evaluating code into it. One of the key things is to make sure that as you make a change, you always evaluate it right then and there. I don't even save the code while I'm working. I will just evaluate a form into the REPL. So my REPL always stays fresh. There are a few Clojure constructs that it's a little hard if you change them to keep the REPL fresh, but there are a couple of things you can do there. One is you can run the remove NS function to remove a namespace and then reload it. And I do actually have that bound to a hotkey. So if I'm working in a namespace and I've got it messed up for some reason, or in particular, I want to change what a require alias is, I will just hit the hotkey to remove the namespace, and then I'll just hit the hotkey to load the namespace back in. And so I can get a clean slate with that. But even when I'm working with Stuart Sierra's component, which we use to manage sort of the start and stop life cycle of things in our production code, even when I'm working with that, I generally don't have to sort of tear everything down. I start everything up once, and by evaluating code into the REPL as I go, the app just stays up and running while I'm working on it. And it's kind of, I feel it's important to point out that if you actually see Rich and Stu working and you talk to them about their workflows, they have very, very minimal tooling. I mean, they both use Emacs, and I think they both use inferior closure mode, but they have very, very little going on. You know, the Rebel has come out of Cognitect, and when you start Rebel up, you get a pretty bare bones REPL, a Clojure REPL. And so if you start that up and you're connected, you know, just through inferior closure mode in Emacs or, you know, the socket REPL, there's no sort of magic happening between your editor and the REPL. You literally are just working with this minimal tooling that's not going to get in the way and not going to interfere with your program. So being effective with REPL, you get like Rich and Stu. If you've Eric Normand in his Purely Functional TV, he has a course about REPL-driven development, which talks about these techniques. And as you watch through the whole of that course, in fact, any of his courses, he's using Emacs and just evaluating code form by form into the REPL. He's not using any magic tooling either. And he talks about how he keeps this very, very simple workflow. Links and resources. I will make the presentation available so that you've got access to everything. My GitHub has the .clojure repo, which has my deps EDN file and my devs CLJ file. It has my VS Code and Clover setup. It also has my Atom and Chlorine setup. and you'll see that the code in those is pretty much identical and the hotkeys are identical. I like to use the Clojure CLI rather than Lineagen because the CLI is, again, a very simple tool that is composable with any of the bits and pieces you need. Lineagen's kind of, everything in the kitchen sink comes with it. So here's links to documentation if you haven't already been using the CLI. There is a REPL tutorial on the Clojure.org website in the guides. Enhancing your REPL workflow is in particular the useful part there, and writing REPL-friendly programs will talk about using the var references so that you can redef a function and have it picked up immediately while you're still working. There's the link to Stu Halloway's REPL-driven development talk, which he gave in 2017 to the Chicago group. And there's a link to Eric Norman's course, because it's absolutely worth the $49 for a month of subscriptions. And I've stayed a subscriber and have been going through a lot of his other courses. I think they're great. If you want to contact me, I'm Sean Corfield, absolutely everywhere. And I do have a blog, and that is generated using Cryogen, which is a Clojure app that turns Markdown into blogs, and it also does ASCII doc as well. So with that, I'm happy to take more questions and dive back into more coding if folks want to ask about that.
Hey, Sean, I have one quick question. So on the Clojure CLI versus Lineagen, do you feel that I see this debate kind of coming up like a lot, especially I feel like it's probably with people first getting into Clojure. If someone is to choose one or the other, do you feel that they will send themselves on a path that's fundamentally incompatible with either one?
No, I mean, because Lineagen was the tool that was out there first, there's a lot more material about it. There's a lot of tutorials that will assume you've got Lineagen. It's still being maintained. So, it's a good solid choice. We started with Lineagen. It was the only game in town when we got started with Clojure. And we used it up until 2015. And in 2015, we switched to Boot. And the main reason we switched to Boot was we were working with a mono repo. We have 36 sub-projects in our mono repo. And working with Lineagen and a large repo like that is a little complicated because it's fairly opinionated about project structure and it assumes certain things. And we needed something that was a bit more programmable. We were finding that we wanted to write quite a few sort of custom tasks around code management. And Boot is a pipeline of tooling. It's not just a build tool. And so, if you want to have a process that, for example, and this is one of the specific things we did, we created some SDK subprojects so that we could isolate certain parts of the code base from other parts. And we had a billing server which actually has a UI and takes credit cards and deals with all that stuff and all the different payment methods. And we wanted to not have any of that code creep in to our main sort of API server. And so we built rules that we implemented as a Boot task that scanned the source code and said, in these sub-projects, you can only require the SDK. And in these projects, you can only require the billing code, for example. And so that made sure that we didn't put direct dependencies between the code because it's all in one big repo. And so we enforced quite a few code rules. It was very easy to write those as tasks. Could we have written them as Lineagen plugins? Probably. But Lineagen plugins just seemed a lot more hard work. Whereas with Boot, you literally can just write a function in a file and require it and then just run it as a task. You can even run it all from the command line. So it's very nice from that point of view. We then switched from boot to the Clojure CLI in, I think, 2018, roughly, whenever the tooling appeared. Partly because we like to stay very current on the Cognitect stuff, and partly because we'd actually begun to run into some bugs in boot. It uses a file set abstraction, and it does it by sort of creating a copy of your file structure into a temporary area, and then it passes it through the task pipeline. And that, with the number of files we had and the size of our repo, that was actually beginning to be a performance problem. And then the other thing we ran into was plain old bug. Boot tries to have the idea of isolated, what it calls pods, that you can run tasks in, so that you can load in dependencies and they don't affect other tasks that you're running inside boot. And part of the way it does this is it has a little pool of instances of these pods, and it refreshes them in the background. So once you've stopped using it, it puts it in the pool and it cleans out the dependencies, and it does it asynchronously. And we started to run into some very peculiar bugs with asynchronous handling of dependencies. I mean, we found things, namespaces would just disappear while we were running our pipeline and things like that. So when we switched the Clojure CLI, it has the benefit that it's a very simple tool. If you want to do something that doesn't come with it, you just write Clojure code and you run that as part of your build pipeline. I showed the -x option when I started this up. That literally lets you run a function. So as an example, let's see, we've got this code. Let's see. Oh, let me just stick a function in here and save it. So it doesn't really matter what it is, but I'll just stick define function foo, and we'll just make it print out the data it gets. So if let me create one that you can actually read. Okay, so if I drop into Clojure-Provo, if I now say I'm going to run, and I need the Clojure-Provo demo foo, so we're going to run Clojure-Provo demo foo, and we're going to pass it a 1b2. And okay, could not locate. Why? All right. Okay. So you know why? Because I'm not in the right folder. There we go. I'm in the right folder now. So I now have my source. Okay. I said live coding, things go wrong.
You did, and so far this is the only thing that's gone wrong, other than your screen going blank.
Yeah, I don't know what's up with my laptop over that. So here we go. Yep, because we've got Jetty, we get helpful logging. Thank you, Jetty. But you see, we get the data printed out as a map. What happens with the -x option on the Clojure CLI is it passes a single hash map to the function being invoked, and whatever you pass on the command line gets added into the things that are in the deps file. So just another example of that, let's just create an alias in here. Create an alias of foo, and we'll say we want to exec Clojure, if I can spell, Clojure-Provo.demo foo, and we will give it some args. We give it a hash map, and we'll say, well, you know what, we'll give it A1B2. And now if I come back to this and say, okay, Clojure, run the foo alias, and that should give me the exact same thing.
Do you need
Thank
a
you.
space?
Thank you.
Or, oh no, did it?
No, because it's aliases, so you say -a, -m, -x, followed by the list of aliases. But the nice thing about this is that you can now say, okay, well, I want to pass in extra stuff. So, and what will happen here is the A I'm passing on the command line will override the default, and the C that I'm passing in will also show up. And so this is kind of a nice flexible way to have literally just Clojure code, Clojure functions, and be able to run them from the command line to do the tooling. So I did it with Clojure -x:new, and that's because, in fact, let me just pull that up. So this is my Clojure deps file, and you'll see here is my new alias, and it says, well, we're going to need the extra deps of Clj new itself, and the default execution function is Clj new create, and the exec is by default a template lib. So one side effect of that is that if I was to just jump up here, if I say -x new, and I just provide the name, by default, that's going to be a library because template defaults to lib. And when I built the little demo app, I said template app because I wanted an application. So it's nice for having default values of stuff. So any other questions? It doesn't seem like it. Oh, well.
There was a question about setting up a watcher. I know you showed how to send data with tap, but I'm not sure that I saw how you set up the watcher.
Yeah, REPL itself has one built in where it's the actual user interface is a watcher that is added as tap. Let me actually just type something into the REPL. So if I said, okay, I want to add tap and just pass in a function, and let's say that we literally just want to print things out that are tapped. So I've added a tap, and now if I come in here and I say, okay, let's evaluate this, which is tapped and it's sent into REPL, but you'll see that it prints out as well. So add tap, you can put any sort of data processing function you want on there, and then you can remove it later. You have to, I think if I remember rightly, you can just do it by, let's just see where the remove tap. Okay, now let's just try, if I now reevaluate it, and it evaluates in REPL, we see it here, but it didn't get printed over here. So you can add and remove functions as you need them.
And when you add a tap, if you're debugging, would you do something like put the data in an atom for later processing or investigating it that way, or what kind of workflow would you go about with that?
It does depend. I mean, one of the tricks that people talk about is putting a def form inside a function so that you can capture the data out into a variable that you can later inspect. You can do the same thing with tap. You could store whatever value is tapped into an atom and then pull out the last value. The automatic display of values that you see in my version, in my REPL that I'm working with, that is actually done using that process. So let's pull that up. Let's see, code, Clojure, dev. So this is the dev script that I've got. And here's the main piece of it, which is where it says, okay, I'll start up a socket REPL. So there's the socket REPL server getting started up, and it actually remembers the port that it started up on and saves it to a file, so that if you start it up in the same folder next time, it'll use the same socket port. It looks for Rebel, requiring resolve on that. It looks for reveal. It then goes and looks for Rebel readline and so on. So we talked about the reveal stuff. That's all in here as well. It's this big function here, install reveal extras. And it does, again, all dynamic requiring resolve, so it can pull in all the different pieces. Clj Fx is an amazing library that Vlad has created, because you can have sort of declarative views of stuff. Let's see if I've got, yeah, this is the function that does all of my table view. And so it's an observable view, which means that it invokes the function every time data is, let's see, how does it work? The view updates every time data is changed in it. So let's see, where is the atom? Last view. I know there's an, oh, there it is, just above the top. So we have last tap, so this is the atom that it stores each value in, and then it adds a tap so that every tapped value is run through this function that resets that atom to the value. So that's basically the same thing. It's the debugging is always save the last value tapped. But you can, the other thing you could do is you can have, for example, you say, well, I'm going to tap a vector where the first element is a keyword that indicates, you know, what this data is. And you could have fancier stuff that says, oh, you know, we'll add a tap function, and the function says, am I given a vector, is the first element a keyword, and then I will have a storage place for each different keyword. And so you can have different taps throughout your code, and it will save the values going through those into different places. So you can make it as fancy as you want for debugging, but the nice thing is that you can just dynamically add tap watches as you need them, and have tap calls throughout your code, pretty much anywhere, sending any type of data value.
Cool, thanks.
Any other questions?
Someone just asked in the chat how you make use of spec.
Okay, yes. Yeah, as I said, we're very, very heavy users of spec. I've written a blog post. If you go to corfield.org, there's a blog post from, let me see which year it was. So, archives, how do you use spec? Where is it? Here we go. So from 2019 September. So I talk about all the different ways we use spec. We use it for data validation in production code. So we have specs for all of the API endpoints, and we actually, you know, conform the incoming data against the spec. And so if it's valid data, we get the nice conformed value, and it's, you know, got all the spec affordances. We use it for test data generation. So even in our unit tests, we will sometimes just do exercise against a spec to generate some random data that we will then pour into unit tests. We do the generative testing. So one of the things that my colleague's done, Hired Man, you see him on Slack a lot, he's very into using spec to generate scenarios. And this is something, if you do sign up for Eric Norman's courses, he has 3 courses on property-based testing, and he shows a technique where you use, you generate operations. So for example, in our billing system, we have a billing admin app, And there's a whole bunch of actions that our member support people can do to an individual membership. You know, they can extend it, they can offer discounts, they can do refunds and so on. So he has specs for what those sequences, what valid sequences of operations can be, and then uses generative testing to generate sequences of operations, things that member support could do, and uses that operations to drive the actual admin code. So essentially what happens under testing is the admin app is driven as if it's got a person randomly doing valid sequences of operations, and then checking that you get to a point at the end where you have a consistent system. And again, it's something that Eric shows in the property-based testing, so that's really nice. We do use the instrument while we're in dev. If we're speccing up code, I recently had to work on a section of the code which I hadn't touched for years and was actually written by a developer who moved on several years ago. And I wasn't familiar with it, so I started writing specs for the functions to see if I could figure out what the data was that was being passed around. And gradually, by writing specs and instrumenting the functions, I was able to get a really good sense of how the data was manipulated and passed around. And it's actually a completely data-driven system that generates SQL queries for interactive reports and charting using Honey SQL. And my colleague was Fumiko Hanreich. And if you go out there and search Fumiko Hanreich Honey SQL, you'll see that she gave a talk at Clojure West about exactly what we're doing with that. And it was that code which, you know, has been running flawlessly, and I just needed to go in and start enhancing it and adding some stuff. And so I needed a better understanding of how it works. So Spec's really good for that. And the other thing that we do with Spec, which is, I guess, a little unusual, is we'll define a spec as the system of record for a data structure with, say, a record structure in the database. And then we will use the spec and derive functions from it. So one of the things you can do with spec is you can ask for the form of the spec, and you'll get back the representation of what that spec had in it. So you'll be able to then walk through the key structure and so on. And we use that in several places where we have a spec. In fact, I was just looking at some code that did that today. Let me think. Can I bring that up? I want to make sure I don't bring up any proprietary code. But essentially, the spec describes a data structure, and then we take the form and we derive the keys back from the spec so that we can process input and select just the valid keys from the input that comes in and discard everything else. So there's the article, and you know, go read it and ask me questions after it. It goes into a bit more detail about the stuff. But yeah, spec is pretty awesome.
Hey, Sean, I got one for you. All right, so I'm just a simple working Clojure developer. If I hadn't been to this talk, I may have never learned about the -X command for about another 3 or 4 years, and there's no way I would have learned about the that special hidden third branch of the tool's depth CLI. So I'm just kind of curious, how is it that you keep a couple of fingers on the pulse here of what it is that's going on? And then the second thing is, speaking of things that I don't know very much about, how do you feel about Growl Vm and how that future there is going to impact REPL-driven development? And is that something we need to be on the lookout anytime soon, or what's sort of going on with that?
Yeah, on the first point, it's true. It can sometimes be really hard to keep up with all the changes. I'm in a lot of channels on the Slack, and one of them that I'm in is Tools Depths. So whenever there's pre-releases of Tools Depths, Alex posts links and information about it. And so, you know, I get a chance to see what's coming there. and I'm always running pre-releases of stuff. So for example, I'll show you just how many different versions of tools deps I've got installed. And I use brew to deal with it all. Let's see, Clojure at, okay, so those are all the different versions of the Clojure CLI I've got installed. Most of them are pre-releases, so that's why they're installed by a particular version. And because they're all installed, I can actually run any of the versions, and so I can test behavior out across multiple versions. But yeah, you've kind of got to know that there are channels where this stuff appears, and you've kind of got to be prepared to spend a little time trying some of this out. Like I say, I like to keep a very simple tool set. So I try as much as possible to keep to sort of fairly standard Clojure stuff and stuff that Cognitect has released or is working on. When we adopted Spec, it was in alpha during the 1.9 cycle. So I think that was one of the early alphas of Clojure 1.9. We always try and run the alphas of Clojure stuff and go and look at the release notes and what's changed and what's coming, and start to try and use those new features in our production code base as we can. We've been very fortunate that the stability of Clojure has meant that we can do that, and we, by pure coincidence, missed the bug that was in Clojure 1.5.0. Kind of one of these little interesting quirks. The release candidate was solid, but the final gold release introduced a bug after the release candidate, and then it was fixed in Clojure 1.5.1. And our cadence of releases at work just happened to fall so that we had the release candidate went through dev QA production, and by the time we came to do the next rollout to production, 1.5.1 had appeared, and so we picked that up and ran that to production, and we never had 1.5.0 in production. And that, I think, is the only time where there's been a bug that would have been pretty detrimental in production. When 1.10, let's see, the JVM changed, and there was an issue with the way that they changed static initialization code of something that caused a huge performance problem if you had user.clj, and we're using Clojure 1.10. We don't use the user CLJ file. That's a file that's auto-loaded. So I guess we kind of dodged that bullet as well. But yeah, there's a lot of stuff out there. There's a lot of libraries. There's a lot of stuff I don't know. I don't do any Clojure script, so I don't keep much of an eye on what's happening in the Clojure script world. And I know that there's a huge amount of work goes on in that area. There's a lot of interesting tooling that's in that area. And the second point, let's see, Growl Vm, yeah. Growl Vm, I think, is of much more interest to tool authors than anyone else. Borkdude, in particular, Mikhail, he has created some really stunning little command line tools, and they are possible because of Growl Vm, because it has such a fast startup time. Babashka, he's got essentially an all Clojure version of the Clojure CLI, just called dep-clj, which is packaged as a Growl VM executable. And the ability to run those things at the command line and just have a very, very fast startup, I think, is particularly valuable to tool authors. I mean, I have some tools myself, the CLJ new, dep-star. Those are things that you would run essentially as one-offs from the command line. But I have not yet felt the need to do anything with Growl VM to make those sort of lightning fast. And for us at work, because our Clojure is all server-side and it's all pretty much all Ring applications, we don't really care about the startup time very much, so Growl isn't useful for us from that point of view.
Cool.
Hey, Sin, I have a question. Can I ask?
Sure.
Yeah. So basically, I'm new to Clojure and functional programming, so I'm more from Java background, imperative languages. So recently, I find it a bit difficult to do code reviews, like peer code reviews, because maybe my less knowledge in functional programming and Clojure. I was just thinking, like, is REPL can give us some more power in doing code reviews like this? I learned about comment expressions today. Maybe evaluating the function under review with REPL. Like, any things which you can share for effective code reviews where REPL can be helpful?
Yeah, I mean, for the code reviews we do, we pretty much just do it all off inspecting the diffs with Bitbucket for pull requests. But certainly, you know, if you were to be in an environment where people wanted to talk about the code and try it out, then having a REPL on hand is very useful from that point of view. I think, I mean, then actually this is one of the things that I kind of do. I mean, I spent a lot of time in the beginners channel on Clojure Slack. And the one thing that I will do when I'm typing into a REPL, pretty much the only time when I'm typing into a REPL is when I'm helping folks with their code. And I will quite literally copy and paste their code from Slack into the REPL. And then I will experiment within the REPL, just typing in slightly different forms to see if I can come up with a cleaner way to do it with core functions. Because this is one of the things that I think really takes time as a Clojure developer, is to learn enough of what's in core and the sort of the basic Clojure package and some of the contrib libraries, that you are aware of the very elegant functions that are available. And this kind of goes back to the question that was asked earlier of how do you stay on top of this? It can be a lot of work. I am still discovering new functions in core, and I've been doing Clojure now for a decade. I've been doing Clojure in production for almost a decade. You know, we first went to production in 2011. I first learned Clojure in spring of 2010. And so I'm still tripping over new functions going, oh, that's a neat function. If you're on Twitter, there is a random Clojure function of the day bot that tweets functions from Clojure. And that's kind of a nice thing to follow, because, you know, every now and then you'll see a function and go, wow, I didn't know that was in core. And I think it tweets the doc string from them, or at the beginning of the doc string. So that's kind of a fun thing. There's a lot to learn, and a lot of ways that you can often improve code. But it's really just a matter of time and playing with it.
Okay. And what is your opinion about like anonymous functions? Because I find them really, I mean, difficult for me to at least understand. Like, once we have few nested level of those functions with INJ kind of variable names. With, like,
yeah, quite a few people have commented on the fact that it seems very, very common in functional programming in general for people to use very short variable names. The logic behind it is, if you have a small function and it's a pure function, that the code should be clear enough that it's obvious what the single letter identifiers are. And certainly, you know, in our own production code, we have quite a few functions with, you know, M for a map, or V for some arbitrary value, or S for a string. And the idea is that, you know, they're small pure functions. The name of the function should make it clear what the code does. But it can be very, very hard when you're learning Clojure, looking at other people's code. And of course, the doc strings in core themselves are very terse. So yes, that aspect is hard. Anonymous functions, I think there are places where it's good to use an anonymous function in code, and places where it really can make it a lot harder to read. I generally don't use the shorthand form with the pound, except in very rare cases where I have a single expression. I don't tend to use partial now. I tend to try and only use comp in a few places, because those are other things that people can kind of fall in love with and write a lot of anonymous functions with. But you know, if I have anything that's more than just a single form taking a single argument, I tend to put it with FN and the actual named arguments. And if it's more than one line of code, then I'll generally define it as an actual named function somewhere. I mean, you can always refactor your code later to have those named functions in, which I think is a good thing to do, so you can clarify the names. But you're right, it's hard when you're learning.
Hey, Sean, just real quick, was there something that made you stop using partial, or yeah?
Stop using what, sorry?
Partial?
It was just one of those sort of changes where, I mean, Rich has talked about, you know, he considers an anonymous function to be more idiomatic in Clojure than using partial. And, you know, it can be a lot clearer sometimes, particularly if you've got a function that's got several arguments. Partial's good if you've just got one argument you're going to supply later at the end, or you've got one argument that you supply now and everything else later. But even then, when you're looking at code, you know, you see partial, some function, and some one argument, and you don't know how many arguments the function takes at that point. There's no sort of real indication of the structure. Whereas if you have an actual anonymous function in there, you'll have names for these things. So, you know, it's much clearer what the anonymous function is doing instead of partial. So those two sort of things combined really is why.
Yeah.
And I pulled open the group chat so I can just go through and see if there's other questions that got asked after my screen went blank and I
There were some questions up there. You have to go up a little bit, but there were 4 or 5. And
yeah, I think I was with it up until, let's see. You know, we've had the security question. Yep.
If you go to about 8:16 p.m., J to everyone, I think that's about where they kind of started coming in one after another.
Oh, okay. So
yeah, I was going to read them off to you, but at the same time, I was sort of hoping you would ask them, so I'm not, you know.
Yeah, so the comma on that, let's see, CRSF issues, okay. Oh, that's interesting that Tori had been dealing with CSRF issues today. Sapan asked that question, yeah, okay. And let's see. The first line of deps EDN seems like magic. The one with the pound underscore, yes. So let me just quickly go back to that. Oh, thank you, group chat. There we go. So the pound underscore is a reader dispatch that reads the entire expression that comes after pound underscore and then throws it away. So if we go into here and we say, okay, we want to map ink across 1, 2, 3, 4, 5, 6, and we'll see that the pound underscore 4 goes away completely. It doesn't turn into nil like a comment form. So if I put a comment form in here, we get an exception because nil is actually passed into ink. So comment 4 evaluates to nil, whereas in that case, it's actually just thrown away. Another neat little trick about this is that you can actually double it up, and that will get rid of 2 things. Gosh, I tell you, I always forget with Rebel that I need to do that. And so you can see 2 numbers disappeared. And this is particularly useful when you're working with key value pairs in maps. So for example, if I said, okay, I want to get rid of the extra paths in this. If I do that, both the extra paths keyword and the value of the key are going to be thrown away by the reader. So that's kind of a nice trick for temporarily commenting out key value pairs in maps. Let's just go back to this.
Cool. So Charlie just had a
Yeah,
question.
there you go. So Mike pointed that out as well. Yep.
Yeah. You can see the chat now, right? Yeah, Sean, can you hear me?
Yeah, I can.
Okay, yeah. Charlie just had a question in the chat about
how much of the code base is macros?
Yeah.
That's a good question. Okay, so let me pull this up. Here we go. So I can answer that by going to developer workspace main build. Okay, so this is the stats from our code base. So we have nearly 85,000 lines of Clojure source code. We have 23,000 lines of Clojure test code. There are just 28 macros in all of that code. We have 3,500 functions, 500 odd vars, def forms, only 28 macros. We do have 89 atoms. We have a lot of atoms that are used in various places for just keeping state while we're doing stuff. And we have a layer, we have a sort of an old-fashioned layer wrapped around core cache. And core cache is a strange thing. It's a caching library that has immutable caches. So if you actually want the cache to get updated, you have to put it in an atom, and then you update the atom with the new value of the cache. So
hang on, Sean. We got questions here. What's going on with this stats.sh? What is this awesome background you have on your computer?
Can you cat bin stats.sh, Sean?
Oh,
you knew you were going to do that, right? You just gave us like some serious.
Yeah. Okay. This is about the ugliest, hackiest way of doing this that there possibly is. It's literally a whole bunch of finds with fgreps and word count lines, WC-L. Part of the reason for this is we exclude things. So let's just see. You'll see I'm excluding this authorized net Google paid Java CLJ file. That's because although it's Clojure, it's generated from it's generated code. So it's this massive, I think, 30,000 line file. It's huge. That's completely generated. My colleague Kevin Hiredman is very big on avoiding sort of repetitive work and a lot of pain for yourself. So he's very big on automating stuff, and so generating a Clojure version of what is otherwise a really, really nasty Java API saves a huge amount of coding. But yeah, so that's all stats.sh. It's literally just word counts and greps. So, how many specs have we got? We look for s/def, how many function specs, s/fdef, and so on.
Do you guys have this, or have you thought about checking a script like this into a World Singles Net GitHub repo?
Well, that one's a bit too specific to our code base to be useful. And I mean, one of the things it also has is our Cold Fusion code, which it goes and gets the line counts for as well. I mean, we release stuff when it is nice and generic. We try not to put stuff out when it's very specific to what we're doing. We do have a whole bunch of stuff that's kind of specific to what we're doing.
The problem is scripts like that are very useful, but I feel like they make us as engineers very self-conscious. Because it's a hack, right? But it's a hack that produces magical results.
Yeah, it's true. And I mean, for example, this is our Clojure code base here. These are all our repos. So you can see there's, I mean, how many is that? It's about 38. So we have 38 subprojects. in a mono repo. And one of the things we have in here is a dev subtree, which just has one function in now. Again, here's a wacky piece of our sort of dev setup. We have a sub-project called Everything. You'll see it here. And all that's in Everything is, oh gosh, I've still got some leftover test databases from when I was playing with NextJDBC. So most of that can go away. The only important thing in here is there's a deps file, there's a classes folder, and then there's the template for building the deps. We used to use the CLJ config environment variable hack with the CLI because we have a sort of master deps file, and then everything else, all the other sub-projects use the master deps file and also their own file. And CLJ config is a way of telling the CLI where your user level deps file is. So we actually pointed it at our master file instead. Now, that was kind of nice in a way because we just relied on the CLI's normal way of taking the system, user, project deps and merging them together and picking up the aliases from them. But it also meant that developers couldn't add their own tooling. It had to be in the repo. So we've recently switched away from that because it is a bit of a hack, even though it is documented. And now what we do is we kind of have a template dependencies file, and we have a process that merges things. So we have a Clojure function that reads a template deps file and project deps file and then generates the real deps from it. Because it's just EDN, so it just slurps it in, merges, and spits it back out. But the dev everything, which I just mentioned, the everything project is how we run our REPLs. So we have those 37 other sub-projects, and we have a little Clojure script that reads the deps from every single project, merges it all together, and writes it out into the everything folder. And then we can run up a REPL in the everything folder, and it has access to all of our code. And if I just more everything deps, so you'll see it's all local roots. And so the everything project has dependencies on all of the other projects. And this is just generated by a little Clojure script that goes through this. And then we pull in the test dependencies from all the other projects as well. And we pull in the test paths. And all of this is just auto-generated based on the other deps in all of the sub-projects. And you'll see it's long. Here's where we pin all of the versions of libraries we rely on. So yeah, we don't want to have to write this manually, we just generate it. And so now when I have a REPL running, I have it running for days, weeks, and I have our entire code base available as dependencies.
Well, that's awesome. That's a sweet setup.
Oh, what's that window manager viewer? What are your windows doing back there? That looks cool.
Oh, this people are often a little horrified at just how many terminals I have open. Is it F10 that's going to do this? No. F11? F9? No, that's not it. Oh, what's the... There we go. So
yeah.
those are all my terminal windows that I have open at one time on my Mac.
That's impressive. Are they all actually executing something?
No, they are mostly not, but they are in different folders. I have a tendency to always run test suites. When I'm running full test suites, I do it from this window. When I am working on our production systems, I just get into the habit of, if a window's in a certain position, I'm going to have it SSH'd into a particular server. So it all becomes muscle memory of, oh, that window's SSH'd in, so it must be on a particular server when I'm working. So, you know, I tend to have a lot of things. This window here is always my blog. So it's always Cryogen running my blog. I have a window, let's see, where's...
Wait, Sean, are you saying you're running your blog out of your personal laptop from
Oh, no. It's generated and then it's put up on GitHub.
Got it, okay.
So it's just, this is the folder where I run Cryogen. So I tend to keep one terminal window always in that directory.
Okay.
So yeah, I'm kind of a little weird, as a bit of a creature of habit there. And if I start cycling through the windows, you'll see also that I have this weird transparency.
That's what I was asking about, the transparency, because I also have lots of windows and I do this weird minimizing window placement thing, but I like this transparent solution. That looks, tell me about that.
It's just Mac does it. I think, yeah.
Oh no.
You gotta go in and set a terminal profile, I think, Sean. Like I noticed you had one for even this meetup.
Yeah, I have. I mean, if I go to, here we go. Oh, and I talked about minimal tooling. I have my taskbar on my Mac hidden by default, because then I don't get distracted by any of the icons in it. I have my dock hidden as well. It's over there somewhere, only it's not popping up for some reason. Let's move this out of the way. Oh, I see why, because I've made this big. There we go. Come on, there it is. It's hiding behind the chat. Come on. There. So I tend to keep all these things hidden, and normally when I'm working, although I've been working with Visual VS Code here just on the display, I normally work with it full screen with Reveal sort of split screened onto it. So, you know, I'd normally have it like this, and then I go to, where did Reveal go? Here it is. And so F9 and stick it up onto the side. And so let's just get rid of that. This is normally how I would have my editor set up when I'm working on a day-to-day basis. So, you know, there's no Chrome, there's no dock, there's no taskbar, there's nothing but editor and REPL with the visualization tools.
And when did you start doing this?
Oh, I've been doing this for years.
Okay.
I do it when I'm working on my Windows laptop as well. I will make things full screen and just dock them side by side with my taskbar hidden. So even on Windows, I have my taskbar hidden when I'm working on a lot of this stuff.
Okay, cool.
So let's see if other questions come up. We did the #_. Yeah, the NS. The only reason I put a namespace in my deps file is because Clover, and I think most editor integrations, when you're evaluating code from a file, kind of assume that it's in a namespace, and so they generally do a trick where they send in NS and the namespace and then the code, so that it always executes in the right context. And so it's kind of just a trick to help the execution of code work properly in there. Have I tried Calva? I haven't, and that's really kind of because it sort of assumes NREPL and it does a lot of stuff that Cider does, and I just want to stick with really simple tooling. And if I'm not working with the socket REPL locally and then I go to work with a remote process, I'm going to have a different experience if I'm used to all of the affordances that come with NREPL and Cider. And the same goes for Calva and other things like that. So again, what I want is a consistent, simple experience across everything. And I mean, I could literally fire up a VPN, fire up a tunnel, and connect my editor to production, and I would have the exact same experience in terms of being able to evaluate code into the remote process. So for me, it's consistency. It's making sure I don't end up relying on things that are part of a more complicated tooling chain. I see a question there about exception handling. Yeah, that's one of those things where you get this giant stack trace, and there's just not much you can do to make your life simpler about that. I keep the REPL minimized at the bottom. One of the things that's kind of a disadvantage with that is if I try and load code and it gets a compile error or it throws an exception, I've got to then either scroll through my little REPL window or make the REPL bigger. I sort of wish that, you know, if an exception occurred, you get it back as data, and then you can at least tap it and explore it as a data structure, which I find is much more useful. And certainly when I'm messing around with stuff myself, I will tend to put a try catch around something and return the exception. Let me just show an example of that just in here. So if I do something like, let's say, oh, well, we're going to divide by 0, catch throwable t. And now when I run that, what I get is a data structure here. And I can actually navigate the data structure. And I can do a lot more with the data structure than I can with, you know, the text output. So then it becomes, you know, for example, let's view this as a table. So this is the stack trace displayed as a table. And we can see, let's just narrow the columns a little. And so we can see the file, and it's much more readable like this than it is just printed out. So again, data is your friend.
Yeah, that's very cool.
Let's see. Okay.
Okay, Sean, I have one
hope
last
I've answered
question.
everyone's questions.
Yeah, I think you did. I went up through the list, and anyone who posted in the chat, I think we pretty much got them. It should save it, so we should have that along with the video.
Excellent.
But I have one last question. So
sure.
I think it'd be awesome if you just, you know, tell us about your love of Clojure and what about it pulls at your heartstrings, and you know, what do you love and what turns you on ultimately. Where do you see it going in the future? Where is it 5, 10, or 15 years from now?
Well, one thing that I really love about Clojure is it's so stable that I can use pre-release versions in production. The core of the language evolves very slowly. So, you know, 5 years down the line, it's still going to be the same language we love today. It's just going to have a few more interesting abstractions added. And if you look at the release history of Clojure, most of the releases have introduced some interesting new general abstraction. In 1.10, the thing for me was Datify and Nav, which provides sort of this nice formalized way of going from some arbitrary object to a pure data representation. And you can navigate and deal with it as Clojure data. And then you can use Nav to say, well, if I got to this point in the data structure and I did the same thing on the original object, where would it get me? And so Nav takes the navigation you've done in pure data and applies it to the underlying object that the data is a representation of. And I think that's a beautiful and powerful abstraction because it's very general. You can use it for generalized laziness. One of the things that I've done with Next.JDBC is built in Datify Nav support, so that if I'm looking at a database table and I have a foreign key, I can nav to that other table using the key. So it lazily loads one or more records from a different table based on a key that I'm looking at. And each of the Clojure releases has had this kind of interesting new abstraction added in. And then everything else, of course, is just libraries. So why did I love it so much? Why was it so appealing? back when I was at university, and now we're going back. I was at university between 1979 and 1986 because I stayed on and did a PhD, and I did a PhD in functional programming. And back then, languages like Miranda and ML and Sassel and Hope, and those were sort of the academic languages that were being created in British universities. And I got into that because in my final year, I was doing math and computer science, and one of the subjects we had to do a special project, and it could be a special project of our choosing. And I decided, having been exposed to APL when I worked at an insurance company for my industrial placement year, that I wanted to write an APL interpreter. And a friend of mine decided that he wanted to write a Lisp interpreter. And so I helped him a lot with testing what he was building. And that got me very curious about Lisp. And the APL interpreter, that was fun and that was fascinating. But I was very intrigued by Lisp, where you have this very, very small core language and you build everything on top of it. And it's all data. The code is data. So I decided I would do a PhD, and the PhD would be the design and implementation of functional programming languages. And I started out with Peter Henderson's, was it Peter Henderson? But LispKit implementation was the underlying thing. And LispKit is a very, very small core Lisp language. And I implemented that, and then I looked at implementing more expressive language features on top of it. And so the process I developed was I would write it in Lisp to try out a new language feature. And if I felt that the language feature worked and gave me more expressive power, I would then implement it as part of the core interpreter underneath. And so, you know, like I say, I was exposed to a lot of other languages at the time that were all functional programming. But of course, no one was doing functional programming in industry back then. And so I went out into the world and became a C programmer after doing some COBOL and stuff like that. Then I became a C++ programmer, and then I became a Java programmer. And let me see, I started doing C++ in '92, and all of the British academics who were doing functional programming had gotten together and designed Haskell. And Haskell was going to be the sort of the one uber functional programming language that the academics could then use to explore all of their theories and all have a common language. And when Haskell appeared, I was like, oh, this is great. It's an uber functional language. It'll take the world by storm. People will just love Haskell, and they'll all want to write Haskell. And of course, that didn't happen. So I stayed a C++ programmer. I became a Java programmer. I still thought Haskell was awesome. And then I got into Scala and started going to a lot of Scala meetups. And there were some very hardcore functional programming people in the Scala community. But Scala was this, typed language, and it wasn't as nice as Haskell, but it was nice. I actually introduced it where I'm working now, initially to try and solve some complicated problems that they had at the time. And I liked Scala, but it didn't really fit well with the team that we had at the time, which were essentially cold fusion programmers who were used to a dynamically typed language where you make a change and you reload it in your browser and off and running. And then I saw some article about Clojure, and so here was another functional programming language that was dynamic. And I thought, oh, that looks interesting. And it turned out that Amit Rathore, the author of Clojure in Action, worked just across the bay from me and was giving a Saturday workshop, introduction to Clojure. And it was $200. And I thought, yeah, that'd be fun. I'll go and spend 3 hours hearing what this guy has to say. And it was a very intense 3-hour course where you went from nothing to building programs. And I was like, oh, this is awesome. It's dynamic. You make a change, and there it is live in your program. And so I introduced that at work, and the Cold Fusion programmers really liked it because it was, kind of what they were used to. They'd make a change in the code and reload, and there it was. And so the fact that management were so open to us using different technology if it solved problems meant that we were able to leverage Clojure for making some parts of the system faster, some parts of the system easier to maintain, more abstract and easier to change and enhance. And over time, we just switched. So, we used to have all Cold Fusion code, and now we have nearly all Clojure code. And I just love that it's so tangible. I love that you can, explore data. When I'm working, I will often have a comment form with, a whole bunch of lines of different data structures and different transforms. And it's a very different way to work than any language where you have to, write out your program, run it through the compiler, see if it passes the compiler, run the result, see if it does what you want. And I love the immediacy of it. So there you go. So that's how I came to Clojure and why I love it so much.
Ah, cool. That's a great answer. That's I'm impressed and surprised by your management's agreement to go from something like Cold Fusion to something like Clojure. I had very much the opposite experience with the Cold Fusion shops that I had joined up on. So that's cool to hear that. They were able to get to those kinds of ideas.
Yeah, I mean, World Singles it's an awesome place to work. I've been here longer than I've worked anywhere. It's a great team of people. They're all about what makes your life better, what gets the job done better, what makes things better for our customers. And so when I came in and said, well, we could try this tech or that tech, and they're like, okay, sure, try it, see if it makes life better for us. Yeah. And we've been able to show with Clojure that the system we've got, when enhancements are needed, it's often like, oh, yeah, we can do that, particularly if we've got something described with data or a spec. And we're like, yeah, we can make this, 1 or 2 line change, and there you go, you've got a new feature. Mm-hmm. I mean, our systems are very data driven. Pretty much everything is in the database or is in a data structure. And then from that, everything is generated or processed on the fly. So we have various sort of rules-based systems. One of the things we've done is if you go to any one of our sites and look for, let me just go and pull one of them up. If we go to, say, arablounge.com, and then let me just move this over to the site. Okay, and so down the bottom, we have Arab singles. So click on this, and here we go. And so this is all generated. This is this part is actually a server-side rendered Clojure app, and all of the categories on this are done through. I think these are just going to be different nationalities, but there's a rules engine behind this that uses instaparse. And our business folks can say, we want a category on here that is all men from Libya. And so they literally can write a rule that says gender equals male and country equals Libya. And we run that through instaparse. We get a data structure. We use the data structure to drive a query that is used against the database. And then these pages are constructed dynamically from a set of rules associated with a site. So our sites has different rules with different names that look for different things, whether they're countries. So here we go, we've got one based on religion, because religion is something that people put in their profile. And so we can just say in the rule, religion is Christian. And that is now a search rule. And so everything's data-driven. And the management team can do an awful lot of stuff on their own. They can actually stand up a whole new website just by entering the data description of the site. So they can define the new domain, they can define all of the attributes of the site, the languages that it's in. So for example, if we go back here, you'll see it's available in French. And so it's all in French, English, back to that, German, and Arabic. And so when you switch it to Arabic, lo and behold, the forms are all right to left now, the labels are all on the opposite sides, and so on. And again, this is all data-driven. It's all about data. And so Clojure is so fundamentally suited to having data descriptions of things and producing results from data.
So what percentage of this capability would you say is a nature or an artifact of your architecture versus what's available on the open source Clojure community?
Well, we leverage open source very heavily. I mean, you saw the deps file, you saw the huge list of dependencies. So I'm not going to claim any credit for that. You know, as I said in one of the opening slides, I've been a senior software architect. That has actually been my job title for 20 years.
Yeah.
When I was at Macromedia, that's the first job I had after I moved to America. And one of the things I did there was to look at overall architecture of how all of the departments at Macromedia communicated and how all of the sales pipeline was processed on the back end. And so, you know, there were some fairly large and fairly fundamental shifts in technology that I was able to drive there. So yes, being the architect does mean that I expect to have a lot of input into systems. And I've been doing software professionally for close to 40 years, I guess. So, you know, that experience also helps.
You've aged well. I have to give you that.
Yeah. Until I went gray, people often used to read my age as a lot younger than I am. So, you know, yeah.
All right, cool. I mean, but it's one of those things, you know, like some architects, especially at like, you know, it's kind of churn of the mill type places, they just download stuff on, you know, from whatever's available. So there's I don't know, to me there's a difference between an architect who can do what you guys have accomplished at World Singles versus like your everyday architect. You know, I mean, that's a pretty damn smooth stack that you guys have there to be able to do what you just described.
Yeah, I'm pretty happy with what we built.
Cool.
You know, and it's kind of interesting. Every now and then we'll have to go in and touch code that hasn't been touched for, you know, 6, 7, 8 years. That's just kind of just been running just fine for all that time. And you know, that's when you see that, oh, we've evolved as Clojure developers because we don't write code like that anymore.
Yeah.
So, you know, having a 10-year-old code base is also a very interesting experience.
Oh, very cool, man. Thank you so much. Yeah, I think so. We're 30 minutes over, but if no one else has any questions, are we all good with calling it there?
I think we're down to 39 people still. So
yeah,
thank you for folks for staying around.
Actually, I do have a question.
Sure.
How much would would you be able to have this workflow if you were using a line for your project? The reason I ask is because we just for most of our projects at the company I work for, we use line again instead of Clojure new.
Yeah,
Clojure
absolutely. I mean, and this was one of the points I made on an earlier slide. Let's just see if I can persuade. Yeah, here we go. Although I use CLI and socket REPL and VS Code you could do all of this with Leinigen, with NREPL, with Emacs VI Cursive. The techniques that I'm showing here are applicable to any tooling. You know, I don't use anything that's particularly special about the CLI or the socket REPL other than an ability to evaluate code. So yeah, you could absolutely start a line REPL up where I started a socket REPL and connect your editor to it and do all of this with Leinigen.
Yeah, cool.
Okay.
All right. Sorry about that. So Sean, thank you so much. This is a really great meetup. Our best one yet by far. So we really appreciate it.
Well, it's a nice group. You guys have some really interesting speakers on, some really interesting topics. So I'm happy to keep coming to the meetup.
I'm really glad to hear that. We love having you, obviously. So yeah, thank you so much, and thank you again for this this talk and for you know, giving everyone just the chance to really see. You know, it's like, you know, a lot of people who are at either beginning level or mid-level, they really wonder about what a guy like you does when he's sitting down at his keyboard. And, you know, a lot of times it feels like some black magic, and you just, you took that, you know, you're like the Wizard of Oz who let the curtain come back for a minute. So that was really great.
Well, you know, and I mean, I think it's important to have folks realize that, you know, despite the years doing this, despite even just the years doing Clojure, you know, I still have to go look stuff up. I still have to refer to the docs. You know, it's very common when I'm working that I hit the docs key all the time to show, you know, oh yes, okay, the function takes these arguments in this order, not that order.
Had some more mess ups in there. I mean, that was pretty good for an hour and a half of live coding. And we talked beforehand. So Sean and I talked about 15 minutes before the meetup, and he was expecting a lot more to go wrong than what went wrong tonight. So that was impressive.
Well, thank you.
So yeah.
And you know, if folks want, I put the contact details up here. You know, I mean, feel free to out on Slack, Twitter, whatever. And ask me questions. I'm happy to dig into anything that I mentioned in more detail direct. So.
Great. Okay, does anyone have any? So we opened it up at the beginning. We kind of didn't do our casual start. But does anyone have any either announcements or just anything that they might like to say? Either Sean or just to the group in general as we part.
Someone's asked about the prezo.
Yeah.
Yet the recording will get posted. I want to hold off until I've given this same experience to the London Clojurians group, so that they don't kind of get the wind taken out of their sails.
What date is that going to be again, Sean?
That is January 12th, and it will be 10:30 a.m. Pacific for me, because it's an evening talk for them. So hopefully that'll be a better time zone for folks who are in Europe. And then once that's done, then this prezo can go up, and I will post the slide deck mostly for the links that are in it, or I'll put a blog post up with all the links. Probably
that'll be great. So I'll go ahead then, and so I'm going to be in Colorado the month of January, and kind of online offline. But what I'll do is I can post it now with a published date of any date in the future. And so it'll just automatically go, and I'll give you the link. I'll give you the login password for that, and then you can attach anything you want to that. So just because we've had quite a few questions on this tonight, actually.
Yeah, it's understandable.
And just in general. And so we'll make sure it gets updated on the 13th of January, a fair date. And then we can post, we had some questions also about the code and then about your slide deck, of course.
Yeah, the code, I mean, it's pretty minimal code, so I'm not sure that there's too much value in posting that. Most of the sort of the stuff that's kind of interest to the workflow is already up in my various repos.
Yeah.
A couple of questions came in here. Let's see, refactoring. Jay Hacksworth, no, I do not use any special tools for refactoring. Again, this is kind of my thing about wanting to keep to very simple tooling that has no magic. I kind of don't like and don't trust code that tries to automatically modify the code I'm working on. So I prefer to do the refactoring manually and doing it piece by piece and evaluating the changes as I make them. So again, minimal tooling, minimal magic, and trying to keep that loop as tight as possible between making a change and seeing the value in the REPL. I know, Cursive does a whole bunch of very clever stuff in terms of finding references to vars. You can rename them. I'm kind of old school. I do kind of prefer a global find and then go in and change things. And I actually will go through and change them one by one. I very rarely do a global find and replace. And another question was about ring versus pedestal. Pedestal didn't exist when we got started with this, as far as I remember. I remember going to one of the Clojure conferences where pedestal was introduced and talked about. And again, pedestal's more code, more to learn, more complex stuff. Ring is simple and does exactly what we need. It's for the same reason that pretty much all of our apps run using the embedded Jetty server. We haven't felt the need for fancier servers. We've got one app that uses Netty because it implements Socket.io. The client is a JavaScript client with Socket.io, and so the backend has to have Socket.io. And there's a Java library for Socket.io on top of Netty. So we went and built that one app using Netty. We use Composure for routing because it's nice and simple. We've got one app that uses Biddy. A lot of our choices are driven by wanting to get the simplest, most composable library that we can for any given task. They're good questions.
I'll just make one quick side comment on Pedestal. I have used it for some of my own stuff, and it is a sweet library. It's more of a code generator, I felt like, than a, at least I use the line again plugin. So I just line new Pedestal app, name of app. And so there's a lot more code than what you might see on like the Luminous stack or those kinds of things. But it was pretty great for a microservice.
Mm-hmm. Yeah. Oh yeah. And I think, once you've got a good handle on how the basics work, then those things aren't, too bad. One of the things I see with people coming to Clojure and saying, oh, I want to build a web app, and people say, well, use Luminous. And so they go, okay, line new Luminous my app. And suddenly they have this directory full of just a huge amount of code and configuration. And, they run it up and it works, and then they make some changes and it breaks. And then it's like, okay, now you've got to start understanding all of these pieces. And it's kind of why I always say, well, start with Ring. Start with the minimal pieces. And it's why I did this demo the way I did, because, start from scratch, add Ring, add a handler, add Selma, so we can have HTML pages, add Composure so we can have roots.
Isn't Ring, okay, my understanding Ring was that it sat on top of like Luminous.
No, Luminous is a template with a huge number of libraries in it. So Ring is the bare bones minimum. Ring is a spec and a bunch of middleware, and the Ring core is very, very small.
Okay, right on.
I do have a question actually, Sean. Did you find a good way of circumventing the Jackson dependency hell, kind of?
There's no good way. What we do is, and I mentioned it just briefly, We pin a bunch of dependencies by using override deps in the deps.adn. And so we've picked a version of the Jackson libraries that works with everything that we have in there, and we have the Jackson libraries pinned per particular version. I think 2.8.11 is what we have it pinned to, if I remember. Let me just see. Grab Jackson. Oh, Jackson, come on.
Because various versions have like vulnerabilities that are not
right.
solved.
Yeah, and we try and keep them in sync so that when we do change, we run Antique, ANTQ. It's a Clojure CLI program that gives you all of your outdated dependencies. And so we run that every day, and it's run by a script, and we check the results into our repo. So we always have a snapshot of the versions we're using and the most recent version that is available for any given library. And so as part of our regular development process, we go through that list and we look and say, okay, we're adrift by 6 versions on this. Let's go and have a look at the change log. Is it safe to upgrade? Is it going to give us some benefits? Oh, it's got a bug fix in for a security thing. Yes, so we'll upgrade. And by running that script every day, we always know, oh, a new version of that library just came out. So,
right,
that's how we manage that.
Cool. Thanks for this.
Okay, cool. Okay, I think we should go ahead and call it that. I don't want to take.
Okay.
Yeah. Thank you, Sean, so much. We've gone 2 hours and 40 minutes, and we did a bunch of prep beforehand. So I mean, I have to commend you. I really appreciate your commitment to this tonight. This was really great. So.
Thank you.
Yeah. So
I've enjoyed it. So yeah, I'm glad everyone came along, and I hope folks got value out of it.
Awesome.
Thanks.
Yeah. So just one quick announcement. So our next meetup is on January 26th at 7 p.m. and it's titled "Why Programming is Folklore and Why You Should Care." And it's with Daniel Bell. So it should be a pretty interesting talk. We've really worked to kind of get him in, and we're excited for that. And then in February is either going to be myself with a riff on what Sean did tonight, with kind of development environment setup. So I did a fairly extensive analysis actually in February 2019 of like Clojure development environment setups. And when Sean and I kind of started talking about this, I thought that should be a cool kind of play off of what he's doing here tonight. Kind of a much more of a development technique than a code itself type talk tonight, which I think is why you were kind of thinking, the code is not the value of what we saw tonight. It was very much how to put that code into the system. And so either February or March presentation is kind of a riff on this. And just announce it here before I even reach out. We're gonna try and get Eric Norman in here to do a presentation, and I think it'd be a great, also a riff. I really like that word right now. It's kind of I've gotten back into my guitar, so a riff on what you did tonight, I think could be well served by a follow on from his as well, and really show everyone both the value of his platform as well as the knowledge he has to contribute to the community. So I think that'd be great. So Sean, again, really appreciate it from the 3 of us, Jacob and Tori and the community here. It was great.
Oh, well, thank you. I'm having some delicious smells wafting in here. My wife has just baked bread. So when I get off this, I'm going to have some fresh bread out of the oven.
All right. Well, thank you. Thank you very much, Sean. This was
okay, folks.
A great meetup. So thanks a lot, guys. So
thanks very much. Good night.
Yeah, cheers. Good night.
Night.